exponents. So for the exponents, there is a lot of topics in this section. Some of them go really fast. Maybe we'll do half of them and take a break and then do the other half. Okay, so the first topic is the power of 10. So an exponent, this is kind of a shortcut way, and I'll show you how to do it in just a second. No, I don't want you to solve it, Apple. But just to go over what an exponent is, 10 to the third means I'm doing 10 times 10 times 10. I'm doing 10 times itself 3 times. You're welcome to use a calculator for that, but really what you do is you count the zeros. That's the shortcut of this one. So this would be 1,000, okay? So the power of 10, what you do with those is you just count the zeros. So on this one, 10 to the 5th, it's really just 1, 2, 3, 4, 5 zeros. So that would be 100,000. That's kind of why they have this topic in there, to show you the shortcut. But remember what you're doing. If you forget that, 10 cubed is just 10 times 10 times 10. All right, when we have negative 2 to the 4th, so what we are doing with an exponent, this is negative 2 times negative 2 times negative 2 times negative 2. The negative is to the 4th power, so like you can do each of these. You have 4 negatives, so it's going to be positive. But if you want to take it one step at a time, you can. Like negative 2 times negative 2 is 4. 4 times 4 is 16, okay? So you can't be careful doing this in a calculator because it does do the negatives wrong sometimes. Maybe the next problem will show me that. We'll see it in a minute. I know I put some on here. But what you are doing is just taking that number times itself that many times. These are just talking about what an exponent is. Okay, 3 times 3 times 3 is 27. The button in a calculator, just to let you know, looks something like this, I think. Or it may have like an up caret. The Alex one is like this, I believe. All right, next topic, same idea. Oh, this is one I was wanting to. So negative 5 squared versus negative 5 squared. This one, so the first one, the negative 5 squared, that is doing, the negative is being squared. So this one is negative 5 times negative 5, which is positive 25, okay? On this one, the negative is not being squared. So what I'm actually doing is I'm squaring the 5 and putting the negative out front. So I do 5 times 5 is 25, and then I put the negative out front. So you have to be careful with this, and this is where a calculator can do this wrong, because if you put this in the calculator without the parentheses, it will actually give you this answer. So is the negative being squared or not? So like, since this is in parentheses right here, you are squaring the negative, whereas this one has no parentheses. Okay, so what you actually do is you square 5, and then you put the negative back on it. All right, what happens if you square or take a fraction to an exponent? What you're going to do on this one is you are going to take everything inside the parentheses to the to the third power. So I do negative 1 cubed and I do 2 cubed. So negative 1 times negative 1 times negative 1. If you have an odd amount of exponents, the answer will be negative, right? I'm talking about if you are taking a negative number to a exponent. So an odd amount of negatives make a negative, an even amount of negatives make a positive. So negative 1 cubed, negative 1 times negative 1 times negative 1 would be negative 1, and 2 cubed would be 8. Okay. The next one, 2/3 squared. So again, you take everything inside the parentheses. 2 squared and 3 squared. 2 squared is 4. 3 squared is 9. 2 times 2 is 4. 3 times 3 is 9. All right, order of operations with some exponents. 2 cubed plus 4 times negative 3 squared. So it is, please excuse my dear Aunt Sally, but remember multiplication and division, when you get to that choice, it works left to right. So if you have the choice between multiplication and division, you work left to right. These are the Facebook memes where people can't do math. That's the trick that they use to get different answers. because everybody thinks multiplication comes before division, but technically they're the same. You work left to right. So you can do the exponents first. 2 cubed is 8. We do not multiply the 4 and the negative 3 because we do the exponent before we multiply. So negative 3 squared is 9. And then 8 plus 36 would be 44. Okay. It is very common when you're just going fast to do 4 times negative 3 is negative 12 and then square it. Do not do that. You got to do the exponent first. All right, so that's kind of our introduction to exponents. Now we are going to exponent rules. The first exponent rule is if I multiply things with the same bases, okay, that's kind of our rule. They always have to have the same base. Like if one was an x and one was a y, I can't combine them. But when you multiply, you add the exponents, okay? When you multiply, you add the exponents. The reason is because x squared is x times x, right? X cubed is x times x times x. Well, how many x's do I have now? I have 5 x's, okay? So the shortcut way of doing that, instead of having to write it all out, is to just do 2 plus 3 equals 5. So I have 2 x's, I add 3 more x's, so now I have 5 x's. This is the first rule, so when we multiply, we add. So a cubed times a to the 4th. Instead of doing all that work, we can just say, okay, 3 plus 4 is 7. We have 3 a's plus 4 a's, so that's 7 a's. Continuing to do the same one. These topics are pretty similar. X, and so x6, I have 6 x's and 3 more, so now I have 9 x's. When you multiply the same base, you can add the exponents. All right, let's get into a harder one here. When you have multiple variables here, you have a number, you have an a, you have a b. Take it one step at a time. You can take it one step at a time. So I would look at the numbers and then look at the A's and the B. Well, the right one doesn't have a number, so it's just 4. My A's, I have 2 A's and then 3 A's, so I have 5 A's. On this one, I do have a 1 there. They don't write the exponent of a 1, but I have 1B on the left side. I got 2 more on the right side, so I have 3 total. So just look at each one individually. Look at your numbers, look at your A's, look at your B's. I'm going to go back. I skipped this one, I think, but we'll do it real quick. So one like this, I'm going to look at my numbers and then my x's. So 2 times 3 is 6. Don't add them. Don't get in the habit of adding them. You add the exponents, not the numbers. 2 times 3 is 6. I got 3 x's on the left, 5 on the right, so I have 8 x's. All right, starting to get into the division. Oh, I wrote 2. That's a 6. Sorry. Okay, so if we multiply, we add. If we divide, we subtract. Honestly, I don't do the subtract way that often. I think about it a different way. I think it makes more sense, but we will talk about it every once in a while. So what we have here is we have 6, we have 3 x's and 2 y's. On the bottom, we have 1 x and 1 y. The way I think about it is, think about them separately again. 6 divided by 2 is 3. I have 3 x's on top and 1 on the bottom. So they're going to cancel out. So that means I have 2 extra x's on top. Okay. And my y's, I have 2 on top and 1 on the bottom. So I have 1 extra y on top. And that would be my answer. I don't have anything left on the bottom. You can do x is 3 minus 1 is 2. So I have 2 extra x's. And then my y's is 2 minus 1 is 1. I just like to think about, I got 3 on top and 1 on the bottom, so I got 2 extra on top. That is subtracting in my head, but it's just the way of thinking about it, and I think it helps when we get to the harder ones. So on this one, do it without having to write them all out. 8 divided by 4 is 2. Whoops. 8 divided by 4 is 2. I have 4 A's on top and 2 on the bottom. So I got an extra 2 A's on top. My B's, I got 3 on top and 1 on the bottom. So I got extra 2 B's on top. We are subtracting when we do this, like 4 minus 2 is 2, 3 minus 1 is 2. But I like to just think about it. And if you get stuck on these, write it out. A, B, B, B. On the bottom, A and A, B. Well, A's cancel out and B's cancel out, so I got 2 A's on top and 2 B's on top. That is what we are doing. That's why this works. Not exactly for sure why it went back to an easier one here, but that's fine. X to the 7th divided by x cubed. If you need to write it out, that's fine. Okay, I have 7 on top and 3 on the bottom, so I got 4 extra ones on top. Technically, this is like x to the 4th over 1 because there's nothing left on the bottom, but we just have to write x to the 4th. So you got 7 on top, 3 on the bottom, you got 4 extra on top. There will come a moment here in a bit where we have more on the bottom. I almost feel like those 2 topics we did before these 2 were wrong. On this one, 10 divided by 2 is 5. I got 5 x's on top and 2 on the bottom, so I got 3 extra on top. 5 minus 2 is 3. Okay. On this one, I draw these lines just to help separate them out. You always do the numbers with the numbers, the x's with the x's, the y's with the y's. You don't have to do that, but so 4 divided by 2 is 2. 6 x's on top, 2 on the bottom. I got 4 extra on top. 3 y's on top, 1 on the bottom. I got 2 extra on top. If you need to write it out, write it out. Write 6 x's and 3 y's on top. Same problem here. 9 divided by 3 is 3. 5 A's on top, 2 on the bottom, so I have 3 extra on top. My B's, 4 on top, 2 on the bottom, so I got 2 extra on top. So when you see these problems on Alex, they do not look very fun to do at all because it looks like a bunch. This is why I draw my lines and just kind of break it into 4 different problems. 12 divided by 3 is 4. 4x is on top, 2 on the bottom, so I got an extra 2 on top. 3 y's on top, 1 on the bottom, so I got an extra 2 y's on top. 2 z's on top, 1 on the bottom, so I got an extra 1 z, You don't have to write 1 as the exponent there. All right, the power rule, honestly, I kind of do this the same way we did the fractions. I try to limit the amount of rules and things to make things easier. When I did the fraction, I said whatever's inside the fraction you take to the third power. So whatever's inside the parentheses, whatever's inside the parentheses you take to the third power. So on this one, I'm doing x squared times x squared times x squared because I'm doing that 3 times. So if I add all those up, this is x to the 6. So the shortcut here is you can just multiply those. I kind of think of like it's a distributive property through the exponents. So the power rule is that you can, when you have an exponent to an exponent, you multiply them.
That'll work every time?
Just multiplying them?
Yeah.
Yes. So on this one, x cubed squared. This is like x cubed times x cubed, but you can just multiply those and get x to the 6th. On this one, xy cubed. All right, this one's a little bit tricky because I got 2. These have an exponent of 1. It's not written, but they do have an exponent. I have to take both of those things times 3. Okay? So I am doing 3 times 1 would be x cubed, and 3 times 1 would be y cubed. What you are actually doing here is you are doing xy times xy times xy. So I have 3 x's and 3 y's. I'm going to change this. Let's put a, no, we can do it there. That's fine. Let's put a 3. Well, I'll put a 4 on that b right there. So let's do 2ab to the 4th squared. Let's do, yeah, that's fine. All right, kind of a trick question here. How many exponents are inside the parentheses?
2.
Why are you saying 2?
Oh, no, because it's all together, so no, it'll only be 1.
Well, give me your thought process why you said 2.
Just because there was 2 different variables in there.
Because there would be a 1 on this A, right? Well, there's also a 1 on the 2. Remember, you do the numbers and the letters separately, okay? So I have to take this 2. There's actually 3 exponents inside here. I have to do that 2. I have to do 2 squared and a squared and b to the 4th squared. So, I mean, if you wanted to write it out like this, you could. But it's easier just to go ahead and do the multiplication. 2 squared would be 4. 1 times 2 for my a would be a squared. And then for my b, 4 times 2 would be 8. Do not forget to square the number. There are 3 exponents. Everything has an exponent. It's just 1, so we don't write it. So there's technically 3 exponents inside there. So you have to square all of them. All right, so I'll ask my trick question again. How many exponents are inside this one? There are 3. So I'm going to take this 3 times all these. So it would be 2 cubed, x cubed, and y to the 6. So it would be 8x cubed, y to the 6. X squared over y cubed. So this is the same thing. It just looks like a fraction. How many exponents are on this one?
2.
There's 2, right? Because there's a 1 right here. So I'm going to take this 3 So it'd be 2 times 3 is 6. 1 times 3 is 3. You have to take, when there's an exponent outside the parentheses, you have to take everything times that. I want to do this one. All right, how many exponents are inside this one?
3.
There are 3. I say that to make sure that you multiply 3 things by 2. So I take this times this and this. This is why I kind of think about it like the distributor property. I distribute that exponent to every exponent inside the parentheses. So you have 2 squared, a squared, and b to the 4th. And of course, 2 squared we know is 4. So we can simplify that part. So x squared, y cubed, and then xy squared. So this is kind of like an order of operations problem. Before we multiply, we want to square. We want to do our exponent first. So I'm going to take this 2 times both of these. So this becomes x squared, y squared. Now I'm going to multiply. I got 2 x's on the left and 2 on the right. So that's 4 x's. I got 3 y's on the left and 2 on the right. So that's 5. Oh, wait. I wrote that wrong. X to the 5th y squared times x squared y. So this one's like multiplying fractions. You just multiply the top and the bottom. So I got 5 x's on the left and 5 on the right, so that's x to the 7th. 2 y's on the left, 1 on the right, so that's y cubed. I can't like simplify those anymore because one's x, one's y. Let's do this one. A to the 4th b cubed over a squared b. Oh, they did that. I'm not doing that. Change this problem a little bit. Hopefully this works. I don't want to jump ahead. I don't know if you'll have anything like this. Okay, so the first thing I'd do is this part right here. So that'd be a squared and b squared. You know what I'd do on the left side? I'd go ahead and simplify that down. I have 4 a's on top and 2 on the bottom. 3 b's on top and 1 on the bottom. And then we could go ahead and simplify the right side. I have 3 a's on top and 2 on the bottom. So I have 1 a left over on top. And then there's no b, so I just leave it on the bottom. This might actually lead into our next topic pretty good. All right, so I can't do anything with my numbers. This is like over 1. Okay, so I'm still keeping everything on top and everything on the bottom. 2 a's on the left and 1 a over here, so that's a cubed. My b's, though, My b's, I have 2 b's on top and 2 b's on the bottom, so I don't have any b's. So nothing's left on the bottom, and I end up with just this right here. Do you want to take a break, or you just want to do it and get it done? Just do it? Okay. All right, there's 2 more rules. This one is the easiest rule of all of them. Anything to the 0 power is 1. So if I see anything to the 0 power, my answer is always 1. I won't go too far into the math of why that is, but math was not invented to torture you. It just follows patterns. So if I have like 3 cubed is 27, 3 squared is 9, 3 to the first is 3, right? What's my pattern? How do I go from 27 to 9 to 3? What's the pattern that it follows? How do I go from 27 to 9? I divide by 3, right? And then how do I go from 9 to 3? I divide by 3. So I'm following a pattern here. So if I do 3 divided by 3, I get 1. So every time my exponent goes down, I divide by 3. This will work for any number or anything. So every time your exponent goes down 1, you divide by the base, and this will always work. So no matter what it is, if it's to the 0 power, it is 1. So even something crazy like this, I do not even have to distribute this through. This whole thing is to the 0 power, so my answer is 1. Anything to the 0 power is 1. All right, so that's the easiest rule. Now the hardest rule. If I have, so let's keep following that pattern for a second. Let me copy and paste this down here. Copy. So if I keep following this pattern, I said every time that I subtract an exponent, I divide by the base, right? So what if I have 3 to the negative 1? Well, I'm going to divide by 3. I got to follow the pattern. Math always follows the same rules. So if I do 1 divided by 3, that's 1/3. Okay? Same thing. If I subtract a 2, I get 1/3 divided by 3 is 1/9. Well, isn't 1/9 the same thing as 1 over 3 squared? Like 3 squared is the same thing as 9, right? So what happens here, my rule here, that's a little harder to understand. That's fine if you don't get it. You just need to know this part. If you have a negative exponent, make it positive by, I'm going to say moving it down. Technically, you can move it up or down. By moving it down. So what I mean by that is 2 to the negative 3. We do not like negative exponents. We always make them positive. So we are going to make this 1 over 2 cubed, and that turns it positive. So we do not like negative exponents. We have to make it positive. So we drop it underneath 1. We move it across the fraction bar to make it positive. And then we can say 2 cubed, 2 times 2 times 2 is 8. Okay. So anytime you see a negative exponent, you make it positive. So 5 to the negative 2, we're going to make it positive by dropping it underneath 1. And this would be 1 over 25. This is a hard one, but it starts to make more sense the more we go. All right. Well, here's the tricky one right here, kind of. 1/3 to the negative 2. So follow our rules before. We have to do everything inside here has to be to the negative 2. So it'd be 1 to the negative 2 and 3 to the negative 2. This is why I said if it is positive, you move it up or down. Because if this is negative, I'm going to move it down here. And if this is negative, I'm going to move it up here. So you have to move it across the equal sign. Or, I'm sorry, move it across the fraction bar to turn the exponent positive. It does not turn the number positive. It turns the exponent positive, okay? You're only changing the exponent. So this would be 9 over 1, which is just 9. Do another one of those. 2 to the 5th to the negative 3. I don't want the ruler. So on this one, this is 2 to the negative 3rd, 5 to the negative 3rd. You have to take that to the negative 3 times, or to everything inside the parentheses. Now let's turn it positive. The 5/3 comes up here. The 2/3 come down there. When I move it across, it makes the exponent positive. 5 cubed is 125, and 2 cubed is 8. Okay, if I have a negative number that I'm doing to the exponent, it doesn't matter. It's still the same idea. I'm not going to mess with this negative at all. But to make it positive, I'm going to, that's the first thing I always want to do, is make that exponent be positive. So I drop it underneath and make the exponent positive. It does not change my base. So then negative 2 times negative 2 times negative 2 would be negative 8. Remember, we don't usually write the negative in the denominator, so it's really negative 1/8. All right, so that's kind of the numbers. With the exponents, or I'm sorry, a variable, it's actually easier. Same idea. We just drop it underneath 1 to solve it. Or we're trying to make it positive. The goal here is to make that exponent positive. So we drop it underneath 1. Oh, here's a trick question on this one. Let's see how well you were listening to me a minute ago. Does my 3 have an exponent? What is it? 1. Okay. So the 3 has a positive exponent, so it stays on top. The y has a negative exponent, so it moves down here. So do not move the number unless it has a negative exponent. All right, so let's mix in some negative exponents to our previous properties. Everything works the same way. You kind of go about this 2 different ways, but when you multiply, you add them, right? So this would be x to the negative 5th. We don't want a negative exponent, so we drop it underneath 1. The other way you could do this, but I think that's probably easier, is make it positive first and then add them. But I don't know if I like that. I'm going to erase that. Okay, so we're mixing in negatives to the same properties. That's probably about all we have left. Oh, no, we got to do scientific notation. But we're going over all those same properties that we just did a minute ago, and we're mixing negatives in. So on this one, again, look at your numbers and then look at your x's. 2 times 3 is 6. My exponents here, negative 3 plus negative 2 would be negative 5. My 6 has a positive exponent, so it stays on top. My 5 has a negative exponent, so it drops down. All right, so when we multiply, we still add. When we divide, we are going to subtract. There's a couple of different ways you could do this one as well. The way that I do it is I just like to turn it positive. I want to deal with positive exponents. So if I 5 is negative, so I move it down here. The 2 is negative, so I move it up here. Well, now I have 2 x's on top and 5 on the bottom. So I got 3 extra of them on the bottom, right? Because x and x, 1, 2, 3, 4, 5. So I have 3 extra x's on the bottom. That is why I was saying that when I subtract them, I always think about I got more of them on top, so I end up with them on top. I got more of them on the bottom, so I end up with them on bottom. Okay? That's the way my brain does it because I want to make them positive. The other way you can do it, and this is where it gets a little hard with the signs, but you can just subtract them. -5 minus -2. -5 minus -2 would be -3, right? So this is x to the -3, which is 1 over x cubed. If you just subtract them, this tells you, since it's negative, it's going to end up on the bottom. When you subtract them, if your answer is negative, it'll be on the bottom. If it's positive, it'll be on the top. So like you really can skip like this step and just go straight to that. Whichever way you want to do it, I don't care. That's fine. I'll kind of write both of them to start. So on this one, 6x to the -4th over 2x to the -1. Okay, so on this one, 6 divided by 2 is 3. Oh, but I got to go do my exponents, right? So my x's, you can subtract them if you want to. But if you want to rewrite them like this, where the 1 is on top and the 4 is on the bottom to get rid of those negatives. So now I have what? 3 extra x's on the bottom. If you subtract them, it would be what? -4. -4 minus -1 would be -3. So since that's negative, it would be on the bottom. I think it's easier just to go ahead and turn them all to positive and then work from there. It might take a second longer, but it's just a second. 8y to the -3 over 4y to the -5. So again, my numbers are easy on this one. 8 divided by 4 is 2. My y's, if I want to make that 5 positive, I move it up. If I want to make that 3 positive, I move it down. So I have 5 on top and 3 on the bottom. So I end up with 2 extra on top. This one does not have a fraction anymore. If you were to subtract these, it'd be -3 minus a -5, which would be +2. Since that's positive, I know it's going to go on top. Either way you want to think about those. Turn them positive and then work it out, or subtract them and then work it out. X to the -2 cubed. All right, so now my power rule. Same thing. 3 times -2 would be x to the -6. I want to make that positive, so I drop it underneath, and that's my answer. So really going back over those same rules, we are just doing them with negative exponents now. How many exponents are inside the parentheses? 3. So I take this 3 times all of these. So 3 cubed, a to the -6, and b cubed. So 3 cubed is 27. A to the 6 needs to come to the bottom to make it positive, and b cubed is already positive, so it stays on top. If it is a negative exponent, you move it across the fraction bar to make it positive. So on this one, Oh, I forgot to write the negatives. I was like, where's my negatives at? That's -4, that's -2. So I take this 3 times both of those, so it's x to the -12, y to the -6. So to make the y positive, it would be 6. To make the x positive, it would be, move it down. You're welcome also to move them first and then multiply. The reason I don't recommend doing that is because if this number happens to be negative, you may have to move them again. Either way would work.
Will we ever reduce the exponents?
Not when they're different variables. That's a y and that's an x. But yes, if they're both x's, you would. So like this one, how many exponents are in there? 3. So I get 2 squared, a to the -6, and b to the -2. 2 squared is 4. A to the -6, to make that positive, it's going to come down here. To make b this 2 positive, I move it up here. All right, back to where we started with the power of 10. What if you have a negative exponent? You're going to put it underneath 1 to make it positive, and then be, again, you put the zeros, 3 zeros because it's cubed. I don't think they'll make you do the decimal. No, I'm not doing that. I think you just leave it as that as a fraction. Okay, last part here is scientific notation. Scientific notation is a times 10. I don't know what letter they use there. I'll use N. A times 10 to some number. This is like when you're dealing with science, you have really, really big numbers, like the moon is, millions of miles away, or really, really small numbers where you have, talking about like microscopic levels. The A, this number right here, has to be between 1 and 10. Okay? It has to be a single-digit number is the way I think about it. Single-digit number. It can be a decimal, like 8.5, but it has to be a single-digit number. The N tells you how many times to move the decimal. Now that I'm going to do this a little bit differently because some people would say left and right. I do not like left and right because if you're going from scientific notation to the standard notation, like the way we write numbers, you would go one way, but then when you go from the standard to the scientific, you'd have to flip it. So if you go left one way, you go left the other way, it gets confusing. So the way, just think about it, okay? When you take math to increase your critical thinking skills, your problem solving skills, just think about it. If N is positive, this is kind of, it's a big number, okay? It's going to be like hundreds, thousands, millions, trillions, billions, okay? If it is negative, it's a, I like small number here because that kind of goes along with what we said. It's a small decimal number, like 0.005 or 0.000000089. Like it's going to be something small like that. Then you don't have to think about left and right and different things like that. Trust me, it's a lot less confusing. Okay. So this 450,000, first of all, where's my decimal to start? After it, right? The decimal's at the very end. We don't write it, but it's right there, right? I'm going to move this decimal until I get to a number, a single-digit number, a number between 1 and 10. So I move it 1 to the left, 2, 3, 4. If I stop right here, I'd have 45, right? I don't want 45. Move it one more. I moved it 5 spots to get 4.5, okay? So that's what I mean by a single-digit number. I do not want 45. I want 4.5. How many times did I move it? 5, 1, 2, 3, 4, 5. Okay. And I'm going to keep it positive because 450,000 is a big number. That's how I remember it. Like if you start doing left and right, it gets confusing because you got to switch it when you go the other way. Okay, so on this one, my decimal is right here. I move it. Whoa. I move it 1, 2, 3, 4. I'm at 720, 72, 7.2. And I moved it 1, 2, 3, 4, 5, 6 times. And again, it's going to be positive because it's a big number, 7.2 million. Don't count the zeros because that's not the right answer. You have to move the decimal. All right, so this one is a small number. It already has a decimal in it. So I'm going to move it this way. 0.034. 0.34 is not right. What about 3.4? Okay, so 3.4 times 10. I moved it 3 times. And this is a super small number, so it is going to be a negative. It's a small decimal, so I put a negative. On this one, 1, 2, 3, 4, 5. I stop right here to make 7.2 times 10 to the 5, and I'm going to put negative 5 because it is a decimal. That means it's super small. Again, I'm sure Alex's explanation is going to say move it to the right 5 because it's a decimal, and if you move it to the right, it's negative. But then when we go the other way, and we go from scientific notation to standard notation, it's going to switch it. And I don't like left and right. It's positive if it's a big number. It's negative if it's a small number. So on this one, we read that a distance to a star is 4.5 times 10 to the 8th kilometers. What I'm going to do, if it's 8, it's a big number, right? I'm not going to think left or right. It's a big number. It's positive. So I'm going to put a bunch of zeros. I don't know how many I need yet. I start moving it. 1, 2, 3, 4, 5, 6, 7, 8. So there's my number. 1, 2, 3, 1, 2, 3. So what is that? Like 450 million. Okay. So this one's going bigger, so I put the decimals to the right. On the next one, it says a cell's diameter is 2.3 times 10 to the negative 5th. This is a very small number. So I'm going to move it to the left, right? So if I'm moving it to the left, I want some zeros to the left. So I move it 1, 2, 3, 4, 5. So this is 0.0000023. Okay. I don't like left and right. Just kind of know that if it's a negative, you got to end up with a small decimal number. And the last 2 topics here are what happens if we multiply scientific numbers. Well, we're going to do this just like we kind of did before. Look at the numbers. 3 times 2 is 6. And then look at the tens thing. What do we do the exponents when we multiply? They have the same base, right? Their base are both 10, so we're going to add them. There is one trick to this, though. I think we'll run into it right here. And honestly, this is hard. Hurts my brain a little bit, but we'll get it right. All right, so here when I do this, 5 times 4 is 20. Then we add these up. That's times 10 to the 7th. What's wrong with that? This number has to be between 1 and 1 and 10. It has to be a single digit number. Okay. So I need to take the decimal and move it 1 over here. So if I make this 2.0, then it will work. But I moved it 1 over. So I'm going to add 1 to its exponent. This is where it's hard to remember if you add 1 or subtract 1, but I'm going from a bigger number, like a 20 to a 2, so I would add it, like. All right, dividing now, kind of the same thing. Do the numbers first. Do this right here. 6 divided by 2 is 3. And then we subtract the exponents. Okay? So kind of just do them separately. And that one's good. We're good to go there. Here, let's really confuse myself right here. Oh, no. Yeah, let's confuse.
Processes to remember.
What'd you say?
So many processes to remember.
Yeah. Well, we're going to rewrite this problem and see if I can really confuse myself here. Oh, no, that can't be 80. Let's really confuse myself then. Sorry, I was trying to get something to happen here because I think it does happen on Alex. Let's just do that. All right, 2 times 10 to the negative 7th. And the problem will probably be written like this. Okay. So 2 divided by 4 is 1/2. You would do that in a calculator, right? 0.5. And then these I'm going to subtract, right? Negative 7 minus 3 would be negative 10. Oh. But this number needs to be between 1 and 10. So to make this be between 1 and 10, I need to take this and I need to move it over here and make it 5.0. I went from a bigger number to a smaller number. And honestly, I've confused myself now on this. It makes it hard. I made it from bigger to smaller, so I need to subtract 1 from there. And I'm going to pull my calculator out and check myself because I don't trust myself. One, 2, 3. 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11. Yes. We're good. It is hard to remember whether to add or subtract when you're trying to, like, it doesn't happen very often, but every once in a while that number, when you multiply or divide, isn't between 1 and 10. And the rule is if you make it bigger, if you're going from a bigger to a smaller, you add. If you make it from smaller to bigger, you subtract. That should always work.